Hi everyone! This week we're going to be doing aeronautical engineering and why it is so important, and we're going to be making some wind turbines together. So let me introduce myself. I'm Skye and I'm a third year aeronautical engineering student at Glasgow Uni, and I'm going to be your mentor this week for aeronautical engineering. So if you have any questions, I'll be happy to answer them. I am a general board member in FemEng, so I don't have a particular role as such. I just help anyone with any tasks that they might need help with. So you may be asking, what does an aeronautical engineer even do? Well, aeronautical engineers are found within many industries such as designing planes, rockets, cars. Basically, aeronautical engineers are involved within designing, building, testing and controlling of machines that use aerodynamics. So aerodynamics is how air moves around things. Now, a great example of how aerodynamics works is if you were to stick your arm out of a moving car safely, it'll fly up. Now, this is because the air under your arm is pushing up, and that is basically how an aeroplane flies. So the wings are shaped in a certain way and placed somewhere in particular to allow it to fly. Now, different planes have different uses, so the plane that you take to Spain on your holidays will have a specific long, slightly curved wing so that it can take you for a nice smooth journey, whereas the planes that you might see in the Air Force have a very different wing. This is to allow them to perform particular manoeuvres and tricks. So aeronautical engineers have to find solutions to getting these huge heavy things like planes and rockets up into the sky and flying safely. So aeronautical engineers like to take objects that are already in everyday life, such as cars, and trying to make them more efficient, potentially faster, always safer, but usually with the intention to be better for the planet, so maybe making the engine more efficient so that it uses less fuel. But for those of you interested in space, aeronautical engineers also try to find ways to make rockets lighter, faster, capable of travelling even further than they've ever been before, and potentially taking humans with them to those places we've never been before. And I mean, how cool would that be? However, there is a lot to consider as an aeronautical engineer when you're trying to make a plane, a car, a rocket, potentially a helicopter more efficient. Something as simple as the shape of a car can be the reason that maybe it's a little faster than other cars. Like, take supercars for example. Have you ever noticed that these really fast cars are really low to the ground? Well, the reason for this is improving their aerodynamics. So when these cars sit really low to the ground, it means that more air is travelling over them instead of hitting the front of them directly. This air that hits them in the front directly slows them down. So because they're nice and low, lots of air is travelling over them, means they can keep nice and fast. So really, aeronautical engineers are just like every other engineer. They're people who are curious about things and want to try and make everyday items better for other human beings. So the current slide on your screen will be showing images where you would find aeronautical engineers working together as a team. There should be a picture of a rocket taking off. Now that is a rocket from a company called SpaceX. You might have heard of them. They have lots and lots of people working together as a team to design, manufacture and launch these advanced rockets and spacecraft. Beside that, a picture in the middle should be a picture of a Formula 1 car. I am a big fan of Formula 1. It's a form of motor racing where the aim of the game is to have the fastest car on track. Now, to make your car as fast as possible, the aeronautical engineers involved in designing the car need to make it as light as possible, think really hard about the shape of it so that it can be super aerodynamic and therefore really fast. The last image on your screen should be an image of a plane. Now, as we discussed before, the plane is super dependent on the shape of the wings, how heavy it is, the shape of the body, and so many other things. There's lots of important questions that need answered by aeronautical engineers when designing all of these things. Now, in today's experiment, we are going to be learning all about how important the blades of a wind turbine are at generating power. Our final result should look a little something like this. This is a wind turbine that I made myself. Now, like a plane flying through the sky where the shape of the wing is really important, so too is the shape of a wind turbine's blade super important at collecting energy. And hopefully, our experiment is going to prove that. Before we start, let's talk about why we're actually doing this experiment. So we've learned that aerodynamics is all about how air travels over an object, and we can use that knowledge when we talk about wind turbines. Now, a wind turbine creates energy that we use in our homes, to charge our phones, to watch the TV, and it creates this energy from the wind. So on a super windy day, the wind will make the wind turbine go in a circle. So we'll have this turning motion. Now, this turning motion provides power to a machine called a generator. And that generator is what is producing the electricity. Unfortunately, we are not going to be able to produce electricity with our experiment today, but we are going to build our own wind turbines and see how fast it moves when we blow on it. This is going to prove how important the length of the blade is, the shape of the blade is. We want our wind turbines to move really quickly when we blow on it. This means that the air is travelling over it really nicely and easily, and that means good aerodynamics. And in theory, that would mean that we've created lots of electricity. It's just a shame that we cannot prove that with our ones. Now, enough of me just chatting about how important aerodynamics is. Let's actually prove it. So for this experiment, all the materials you will need will be on the screen right now, but I'll just go through it with you anyway. So we're going to need paper or card, totally up to you. I used paper just because it bends a little easier. You're going to need glue or tape. I used glue, but again, it doesn't matter. It's really just so that when we fold our paper over, we can make our blade. You will need a straw, whether it be plastic or paper. It's again, totally up to you. All we need to do is bend that straw over. So I used a plastic one purely because it already has that wrinkly bit, so it was nice and easy to bend. But if you want to use a paper one, that's fine. You're just going to bend it over. After that, you're going to need some scissors so that we can cut our paper. You'll need a pen or pencil so that we can draw our lines. And you will need a ruler so that we can make those lines nice and straight. If you want to go and collect those materials, I recommend you pause the video, go and collect them, and then we can get started. Hi everyone, so by now you'll have gathered your materials to make your wind turbine. So you should have some paper, a straw, whether it's plastic or paper, scissors, a pen or pencil, a ruler, and glue or tape. So I'm going to be using glue, but it's totally up to you. So to start off, you're going to get your piece of paper and we're going to cut it into a square. Now, it's up to you how big you make your square. This is what's going to make the blades of our windmill. Now, I'm going to cut my square 6 inches on each side, but it's totally up to you how big you want to make it, how small you want to make it. This is what being an engineer is all about. So I'm going to do 6 inches. I'm just going to mark up my paper. Then once you have your square, you're going to cut it out safely using scissors. Right, now once we have our square, so I'm just going to move this stuff out of the way so we have some room. Once you have your square, we're going to draw diagonal lines from corner to corner. So let me grab my pen. Just one diagonal line from one side to the other. And then same again, from one corner to the other corner, we're doing a diagonal line. So once you've done your diagonal line, your square should look like this. What we're going to do is we're going to mark up 3/4 of the way of our blade. This is going to allow us, so when we cut, because what we're going to do once we have this marked up, we're going to cut all the way to the mark, and that's going to give us our blade shape. So if we're going to cut, we're going to mark them up So if I mark it from here, so I done mine, so because my square is 6 inches on each side, I'm just going to mark up 1 inch, so you don't even need to make it 3/4, as long as you have it somewhere near the middle. So I'm making 1 inch, that seems good enough. So I have marked them 1 inch from the middle. So I've got my wee marks, and that's just 1 inch from the center. And that's what your guys are going to do. So you're going to leave 1 inch. Once you've done that, you're going to take your scissors again, safely. We're going to cut along this line up until we reach the mark that we just made. So let me just start cutting. And then do it for all 4 corners. Once you've done that, your square should look a little something like this. It should look nearly like triangles that are nearly full the way cut out. Once we've done that, we are going to cut little holes at one corner in each of our triangles. Now that is going to mean that when we bend over our blades, there's room for the middle. So take one corner, you're going to fold over, to make our hole, we're going to fold over the corner, take our scissors and cut a little triangle. Now that little triangle, when you open it up, will look like a wee diamond, and that diamond is where our straw is going to fit through when it goes in the middle. So we're going to do that for all 4 corners. So you'll make one there, and then one here. So pick a corner. So I'm doing mine in the right side of each. So I'll do it again, fold it over, cut a wee triangle. There's another one. And then we're just going to do it with the last 2. And then the last one. Just careful with your fingers, nice and safe. When you're done that, your square should look like this. You'll have 4 diamond shapes in each of the right corners. And finally, all we need to do for the cutting wise is now we need one in the middle. And in the middle is where our straw is going to go through. So again, just fold it over. You should already see from the back, you'll have a wee X. So there's exactly where you're going to cut. Just fold it over slightly again. And same again, we're going to do a wee diamond, so cutting a triangle out. And once you're done that, this is what your square should look like. So you should have a diamond in the middle, right here, and then 4 diamonds in the corners. 1, 2, 3, and 4. Once we've done that, we're going to bend the paper over, and that is going to make our blades. So you're going to get one corner. This is where we're going to need either our tape or our glue, whichever you're going to use. I'm going to use glue. So we're going to start gluing. So from the center, so we're going to fold them in to the center. So it's going to sit like that. The hole is going to sit over the other hole like this. And that, you can see, is going to make our blades. So when we do it with all 4 of them, eventually when we glue all 4, you're going to have a blade shape. So start off by gluing the first one. You don't need too much glue, just enough that it'll stick on. There we go. So then line it up with the hole so that you can still see the hole, because this is where our straw is going to go through. Then next. Now this may need some time to dry if you're using glue. Sometimes the glue is obviously a bit wet for a while. So again, just gluing. So we've still got our hole in the middle there, so you'll still see the hole in the middle. When we line them up, that hole should always be there because that is where our straw is going to go through. And the last one. So that should be your blades finished. Now again, if you're using glue like me, it might take some time to dry, but this is what your final result should look like once you have lined up all the holes. So mine just needs a little time to dry with the glue, so we're going to put it at the side while we deal with our straws. So the straw is going to make the shaft. That's going to be what, if this was a real wind turbine, would be sitting here like that. So I'm just going to let this dry, but this is what yours should look like. So you should have 4 blades, maybe differing in length if you made yours bigger or smaller than my square, but either way you should have your little hole in the middle, which is where the straw is going to go through. So I'm just going to leave that at the side, just let it dry for a bit. So now that we've put that down to the side just to let it dry, we're going to have to make the shaft, which is like the body of the wind turbine. So this is where you'll take your straw. Whether you've got a plastic bendy one like me, it's just a matter of bending it over like this, and that's you done with it. But if you have a paper straw, what you're going to do is you're going to take your ruler and you're going to find 4 centimeters. So that's here, so it's this big. And you're going to bend your paper straw 4 centimeters down. So if you've got a paper straw, imagine this was paper, find 4 centimeters and bend it from there. That's what you're going to do. Unless you've got a plastic one like me, then you've got that wrinkly bit, it's bent already. So what you're going to do is you're going to stick that through your hole here, and that's going to fit through like this. But we're not finished quite yet, nearly. But if we leave it like this, the wind turbine, when we blow on it, it's just going to fall off like that. So what you're going to do, if we look at the one I made earlier, you've got little cuts here. So I've cut the straw into 4 separate bits. It just means that the wind turbine will not fall off. So it's staying on, the blades are staying on. So that's what we're going to do with our straw. So I'll do it, showing you it just without putting it through yet, but you guys will cut it with the blades on. So actually I'll do it with these. So what you're going to do is you're going to take your scissors, again safely cut 4 little lines in your straw, 3 or 4, it's up to you, as long as, and then spread them out. So spread these out, 2, 4, so you're just going to spread them out like this. So it's just going to sit like that. And once you've cut like this, it means our wind turbine's staying on. So that's us finished actually. So this is your wind turbine. So mine is still a little wet from the glue not being dry. So your final result, when you're finished, should spin like that. So you can now go out and test your wind turbines and see what you think. So as budding engineers, you can say to yourself, did I make my blades too short? Are they too long? What would happen if we cut more than 4 blades? Would it turn even faster? Would it go even faster if we had less than 4? So if we just had 2 blades, what would it go like? These are things that you can ask yourself. Other questions you might ask are, instead of the square we made at the very start, so when we made our square on the paper, you can say, what if I made a circle? And then cut blades from there. Because obviously, the blade shape would be different. Instead of these kind of pointy edges that we'd have more rounded edges. Would that collect electricity better than our ones? That's something you can ask yourself. So once you're finished your wind turbines and the glue has dried, or if you've got tape, you should be ready to go. You can test them out, blow on them and see how fast they turn. So I hope you had fun making that, and you can make your way back to the slides. Welcome back to the slides. I hope you enjoyed making a wind turbine with me. and learnt a little something about what exactly is aeronautical engineering. Well guys, that is me finished. I'm sure you've already been told this, but I just want to remind all of you that if you ever want to get in contact with any of the FemEng mentors, please do not hesitate to contact the email address on the screen right now, femeng@gues.org.uk. If you have any questions, we are beyond happy to answer them. Please feel free to send us any pictures of you all making your wind turbines or with your wind turbines. I hope you enjoyed today and I cannot wait to see you all soon. Bye everyone!